Mars 2020 rover.
Oh man, where do you start? What excites you about Mars missions? One, it's one of our closest neighbors. Two, it's the one that we think has the greatest potential of having life that we might be able to find in the near term. It's the first place we actually went to with a lander. So it's a very intriguing place. It's a hard place to go. You have to worry about all the drag effects and that help you slow down, but also all the friction aspects. And you can't slow down enough to actually land, so you have to add all these other features. So it's a lot of fun for us engineers trying to figure out how do you go solve those problems that are pretty complex. So MEDLI 2 stands for Mars Entry, Descent, and Landing Instrumentation number 2. It's a suite of sensors that are on the aeroshell that's around the Perseverance rover. And our job is to collect information on what the environment is as the aeroshell traverses through the atmosphere of Mars. That helps us understand a little bit more about how the vehicle is performing. It helps us get information which we can then use to improve our models and our predictive capabilities for future Mars missions or future entry missions of any kind. We did something similar back in 2012 on the MSL mission, so this is a natural extension off of that. So one of the key differences, the first MEDLI had instrumentation on the heat shield, the front-facing part. With MEDLI 2, we have a lot of instrumentation on the back shell, which is the structure that sits around the rover. On the back shell, we have a lot of uncertainty on our analytical methods. So by having sensors on the back, that lets us reduce that uncertainty so that we can improve our models even more. We also have a few other sensors on the heat shield spread out in a little bit different orientation that lets us understand different thermodynamic phenomena, flow phenomena, so we can assess things that we did not assess during the first MEDLI. So what MEDLI 2 will bring to the table to help us learn new things at landing, the information about how the vehicle actually performed as it went through the atmosphere, get information about the density. We'll get information about how the flow maybe goes around in the back and what happens in the back, which then helps us understand drag phenomena, heating phenomena. So then afterwards we might be able to reduce the amount of insulation we have. That reduces the mass that we have to send to Mars, which saves money, or lets us turn that mass into something that's on the science side. So maybe we can save 10 kilograms of that mass and put in 10 kilograms of a new science instrument. So those kinds of things in terms of how we might do things differently, that's all part of what we're going to learn.